So I want you to try and imagine a bird, just any bird.
Okay.
But now I want you to strip away literally everything that makes it graceful in your mind.
Oh, so we are going weird right off the bat today.
We're going incredibly weird. I mean, give this bird a literal claw on its wing, like some sort of resurrected velociraptor.
Right.
And give it a built-in comb on its toe. Oh, and polarized sunglasses built directly into its eyeballs.
It sounds like a sci-fi monster at this point.
Exactly. And give it a daily routine that involves actively stalking crocodiles through the mud. You aren't imagining a dinosaur, and you aren't imagining a monster. You are imagining the African Finfoot.
It is, quite frankly, a creature that completely shatters our human need to categorize the natural world.
Yeah.
Because, if you look at a mallard duck, you instantly understand its evolutionary blueprint. But the Finfoot is this total anomaly that just thrives in the absolute murkiest corners of avian taxonomy.
Well, welcome to the Deep Dive. Today, we are tracking down one of Africa's most elusive, sought-after, and, frankly, baffling aquatic birds.
It really is.
And if you've ever spent any time looking for birds, you know this one is considered an absolute holy grail. So to help you, our listener, grasp the sheer weirdness of this animal, we've pulled together an incredibly rich stack of sources today.
We've got a really great pile of material to go through.
We really do. We're talking first-hand field notes from the Lark magazine, specifically the legendary Obsessive Observations of Derek Engelbrecht.
Those are amazing.
They are. Plus, we have insights from wildlife documentaries by Johan Vermeulen, these hyper-specific nature reserve guides from Fairview Hotels and Sipsicama National Park, and expert birding blogs dedicated to South Africa's garden route.
And what's remarkable about this stack of sources is how consistently baffled the observers seem to be, like all of them.
Yeah, they all sound so confused.
They do. They all point to the central paradox, because here is an aquatic bird that belongs to the family Heliornithidae, which actually places it genetically closer to cranes and rails than to anything resembling a duck or a cormorant. It lives its entire life on the water, yet it seems to possess this deep instinctual aversion to flying.
And when it swims, it violently bobs its head back and forth like a city pigeon pecking at pavement. It's a bird that has completely mastered the art of vanishing in plain sight.
Oh, absolutely.
And I want to jump straight into how it manages to do that, because ornithologists have given the African Finfoot this nickname that sounds like a complete oxymoron. They call it the obliging skulker.
Which is such a funny phrase. It sounds like a contradiction in terms, but it perfectly describes a survival strategy based on basically cold, calculated risk assessment.
Okay, break that down for us.
So the skulker half is really evident in their habitat choice. I mean, they require the deepest shadows, the overhanging vegetation, the tangled roots of muddy riverbanks.
Right, they hide.
Yeah, but the obliging part speaks to a very rigid set of behavioral rules they follow when they actually encounter humans.
Because they don't just fly away.
Exactly. Unlike a heron or a duck that will just flush and take to the sky the second you snap a twig, the Finfoot operates completely differently.
Which brings up this unbelievable anecdote in Derek Engelbrecht's field notes. I mean, it perfectly illustrates this.
The beach story.
Yes. He talks about his very first encounter with a Finfoot. And the crazy part is, it didn't happen in some dense, inaccessible jungle. It happened on a public beach at Mtunzini, where this small coastal stream just empties out onto the sand.
And the geography there is really crucial for you to picture, because you have the open, exposed beach contrasting sharply with the sheltered, vegetated stream edge.
Right. So Engelbrecht and his girlfriend are just sitting on the beach, staring out at the crashing ocean waves. They're completely still, just relaxing.
Not moving at all.
Right. And out of his peripheral vision, he spots something moving. He slowly turns his head, and there, maybe 10 meters away, is a female African Finfoot.
Just right there.
Just walking along the edge of the stream, pecking at unseen invertebrates in the sand, casually wading into the water. Like, she seemed entirely oblivious to these two massive humans sitting right next to her.
And that observation brings up a really fascinating point about avian sensory perception, because I think many people assume that if an animal doesn't react to you, it must not see you.
Yes. My brain immediately went to the T-Rex from Jurassic Park.
Yeah.
Don't move. Its vision is based on movement. Is the Finfoot actually nearsighted? Does it just have terrible eyesight?
It's so tempting to think they are nearsighted, like that T-Rex myth, but the biological reality is actually way more terrifying.
Really?
Oh yeah, they see you perfectly. Their visual acuity is razor sharp.
So it knew they were there.
100%. They are just running a cold mathematical calculation that staying still keeps them alive longer than running. Field researchers note that when a finfoot swims past a stationary observer, sometimes as close as 2 meters away, it is constantly giving these subtle cursory glances. It is acutely aware of your breathing, your presence, the exact shape of your silhouette.
So it's looking right at you, knowing you are a potential apex predator, and actively choosing to ignore you. That is wild.
It's trusting its evolutionary programming over panic. For most birds, the immediate metabolic response to a threat is flight. You burn the energy, you gain altitude, you survive.
Right, standard bird stuff.
But flight exposes you. If the finfoot takes to the air during the day, it suddenly becomes highly visible against the sky to an African fish eagle or, say, a crowned eagle.
Eagles.
Right. So the calculation is, if this ground predator isn't actively charging me, I am safer relying on my camouflage than I am exposing myself by flying.
Which means we need to talk about that camouflage.
Yeah.
Because if you were going to literally bet your life on blending in, you need a serious disguise. The sources mention that at a quick glance, you might mistake them for a small cormorant. They sit very low in the water, very sleek, but the coloration is just wild.
It really is a masterclass in disruptive coloration. The back is a rich rufous brown, heavily spotted and mottled.
Sort of a messy pattern.
Exactly. To a predator looking down from above, that broken pattern mimics the dappled sunlight hitting dead leaves and muddy water perfectly.
But then you have these flashes of absolute neon. Like, it has a white belly, a bright white stripe racing down the side of a dark, greenish-black neck, and then the real shocker, this incredibly bright reddish-orange beak, and massive bright orange legs with yellow claws.
And those bright colors might seem completely counterintuitive for a stealth bird, right?
Yeah, I would think you'd want to be all brown.
Yeah. But in the deep gloom of an undercut riverbank, bright colors can actually break up the solid outline of the animal, making it harder for a predator to recognize it as a bird.
Oh, so it's like biological dazzle camouflage. It confuses the eye.
Precisely.
But those neon orange legs are far more than just a paint job. I mean, the anatomy of this bird's foot is where the real evolutionary weirdness begins for me. When we think of aquatic birds, we instantly picture the webbing on a duck's foot. But the finfoot doesn't have that.
Not at all. Their feet are what evolutionary biologists call lobate.
Lobate.
Right. Instead of a continuous membrane of skin stretching between the toes, each individual toe features a series of fleshy, paddle-like flaps or lobes running down its sides. You actually see this in coots and grebes as well.
But why develop lobes instead of a solid web? If you spend your life swimming, wouldn't a solid web push more water?
A solid web is excellent for pure open water propulsion, sure, but it comes with a massive biomechanical penalty on land.
Oh, like how ducks walk.
Exactly. Think about how a duck waddles. That solid web forces a clumsy, flat-footed gait, and the finfoot lives in a highly structured, tangled environment. It constantly moves from water to mud, up slippery logs, and through dense reed beds.
That's so they need to walk normally.
Right. Logate toes are basically an all-terrain solution. When the bird pushes back in the water, fluid dynamics force the fleshy lobes to flare out, creating a broad surface area to catch the water.
Like opening a parachute.
Exactly. But when the bird steps forward on a muddy bank, the lobes fold back smoothly against the toe. It reduces drag and prevents the foot from snagging on roots and vines.
That is just brilliant engineering. A collapsible paddle that turns into a streamlined climbing claw. But the sources reveal another feature on that foot that honestly sounds like a practical joke. The middle claw on each foot is pectinated.
Pectinated meaning comb-like.
Right.
The inner edge of the claw on that middle digit has a literal row of fine, rigid, tooth-like serrations.
Okay, so I know nightjars have pectinated claws, but nightjars are aerial insectivores flying through the dark catching moths. Why does a water bird creeping through the mud need a built-in comb on its toenail?
It all comes down to the microscopic warfare happening on the bird's skin.
Wait, warfare?
Yeah, a bird that spends its life dragging his body through stagnant, muddy, parasite-rich riverside vegetation is going to attract a massive load of feather lice and mites.
Oh, ew.
Yeah, and if left unchecked, those parasites degrade the structural integrity of the feathers. For a water bird, compromised feathers mean a loss of waterproofing and thermal insulation, which is essentially a death sentence.
So they use the claw to literally comb the lice out of their feathers.
Exactly. They contort their bodies and use that serrated edge to meticulously groom their plumage. They align the microscopic barbs of the feathers while physically scraping away parasites. It's an indispensable hygiene tool welded directly to their anatomy.
Okay, An all-terrain, collapsible paddle foot with a built-in lice comb. That's weird enough, but we have to talk about the wings now. When I was reading the notes from the lark, I honestly had to stop and reread the sentence 3 times. The African Finfoot has a literal claw on its wing.
It is arguably one of the most astonishing anatomical anomalies in modern avifauna.
Couldn't believe it.
And we aren't talking about a carpal spur, like a blunt bone protrusion that some birds, like spur-winged geese, use for bludgeoning rivals in a fight.
Right, not a weapon.
No, this is a 12 to 18 millimeter sharp, bright orange claw located at the end of an independently movable first digit on the wing itself.
An independently movable finger on a wing. That brings us straight back to the Archaeopteryx.
It really is a profound glimpse into their evolutionary past. All birds actually possess the latent genetic architecture for wing claws. It's locked away in their dinosaur DNA.
Wow.
But almost all modern birds suppress that gene expression before they hatch. The finfoot is one of the rare exceptions that actively expresses it.
Wait, okay, so the Hoatzin in South America is famous for having wing claws, but it only uses them as a chick. It loses the claws entirely as an adult once its flight feathers come in and it can fly. But if the finfoot keeps this claw into adulthood, that implies their adult environment is so tangled, so completely prohibitive to flight, that evolution decided they still need a hand to pull themselves through the branches.
It goes even further than that, because we're not just looking at a retained juvenile trait. We are looking at a daily functional adaptation.
They use it every day.
Yes. The finfoot's habitat is a chaotic, three-dimensional maze of overhanging riparian forest. To navigate that space, to climb up into a tree, to roost, or build a nest, they literally clamber.
They climb trees.
They do. They use those lobate feet, and they reach out with that movable wing digit, gripping the bark with the orange claw to hoist their body weight upward.
It is genuinely difficult to picture a sleek waterbird rock climbing up a vertical tree trunk using a thumb on its wing.
It's quite a sight.
I bet. And that bizarre method of getting around brings up another physical mystery. From the source is the tail. The African finfoot has a very broad, stiff tail that it fans out onto the surface of the water while it swims.
Yes, and for decades, ornithologists assumed that fanning the tail was a hydrodynamic adaptation.
Right, that makes sense.
The logical assumption was that it acted as a rudder for tight turns, or perhaps that laying it flat on the water reduced the bird's wake, allowing it to swim more stealthily.
Which makes sense on paper. I mean, if your entire survival relies on not being seen, minimizing your ripples seems like a really good strategy. But the field experts in our sources aggressively push back on that, don't they?
Very strongly. Researchers who have spent hundreds of hours in the field point out a glaring flaw in the stealth theory. A fan tail dragged across the surface of the water absolutely does create a wake.
It makes ripples anyway.
Exactly. In fact, a finfoot leaves a highly distinctive V-shaped ripple behind it. So the tail is failing as a stealth device. Instead, the leading theory is that this specialized tail evolved for a purely terrestrial purpose.
Wait, a terrestrial tail on an aquatic bird. How does that work?
Think about the biomechanics of a woodpecker.
Okay, a woodpecker.
Woodpeckers possess incredibly stiff, rigid tail feathers. When a woodpecker clings to the vertical side of a tree, it drives that stiff tail into the bark below it, using it as a prop.
Oh, like a tripod.
Yes, it creates a stable tripod, 2 feet and a tail, allowing it to lean back and hammer into the wood without falling backward.
Oh, wow. So when the finfoot is using its lobate feet and its wing claw to clamber up a muddy, slippery riverbank, it's using that broad, stiff tail as a kickstand.
Precisely. It's a third point of contact. And the physical evidence for this theory is overwhelming. If you examine the tail feathers of a finfoot, even feathers that haven't been molted recently show an excessive, almost violent degree of wear and abrasion.
Like they're getting beat up.
The keratin is frayed and ground down. You do not get that kind of structural damage from dragging a feather through soft water. They are physically grinding their tails against rocks, abrasive mud, and rough bark to maintain their balance.
Man, the more we unpack this, the more this bird sounds like a highly specialized tactical operative.
That's a great way to put it.
And speaking of tactical gear, I have to ask you about the eyes. The sources specifically highlight the bird's nictitating membrane. Now, lots of animals have a third eyelid, but the finfoot seems to use its membrane in a very specific, constant way.
So the nictitating membrane is a translucent inner eyelid that sweeps horizontally across the cornea. Usually birds deploy it briefly to moisten the eye or protect it during a strike, like a falcon diving.
Right, just a quick blink.
But field observers note that the finfoot keeps this membrane partially or fully extended for long, continuous periods while foraging.
Wait, they're just walking around with their eyelids closed.
Not closed shielded. You have to consider the optical physics of their hunting environment. They are searching for microscopic movement on the surface of the water. The dappled sunlight piercing through the forest canopy creates intense, blinding flares of glare on the water's surface.
Oh, it's the exact same reason fishermen wear polarized sunglasses to see into the water.
Exactly. The prevailing theory is that the finfoot's extended nictitating membrane acts as a biological polarizing filter.
That is insane.
It cuts the surface glare, penetrating what we call Snell's window in the water, allowing the bird to clearly see the aquatic invertebrates just below the surface line, all while physically protecting the eye from the sharp tips of reeds and thorns as it pushes through the undergrowth.
So it literally has built-in tactical goggles.
Basically, yes.
Okay, so we have this heavily armored, climbing, polarized stealth bird. Let's talk about how this machine actually moves in the water. We teased it earlier, the head bobbing. What is the actual mechanic there?
It's a highly rhythmic, almost mechanical motion. With every single alternating stroke of its lobate feet, the finfoot's head thrusts forward and backward.
It totally ruins the illusion of a sleek, stealthy phantom when it's just bopping along to a rhythm only it can hear.
It may look comical, but it is an incredibly sophisticated neurological tool. When a bird bobs its head, it isn't actually moving its head backward.
Wait, what?
What it's doing is thrusting its head forward, locking it perfectly still in space for a fraction of a second, and letting its body catch up.
Wait, really? The head is stationary while the body moves?
Yes. It's a mechanism to process optic flow. Because a bird's eyes are fixed in their sockets, they can't track smoothly like human eyes. If their head moved smoothly with their body, their entire visual field would be a blurred, dizzying mess.
Oh, like taking a panoramic photo while shaking the camera?
Exactly. By locking the head in place, they stabilize the image on their retina. It's called saccadic masking. They get a sequence of perfectly sharp, high-resolution still images, which is absolutely critical if you are trying to spot a perfectly camouflaged water beetle on a moving current.
That makes perfect sense.
Yeah.
Wow. So this hyper-visual calculating bird is bobbing along. What happens when the risk calculation fails?
Oh.
Because we established that they rely on camouflage, but let's say a crocodile lunges, or a human actually steps on a branch right next to them.
Yeah.
If sitting perfectly still fails, what is the escape plan?
Total explosive chaos.
Chaos.
When genuinely startled and forced to abandon their stealth, they very rarely take to the air in a graceful, sweeping flight. Instead, they execute this frantic walking on water escape.
Which brings up the African's name for the bird. It perfectly encapsulates this, doesn't it?
Yes, the African's name is water trapper, which translates directly to water treader.
I just picture a cartoon character spinning its legs in a blur before shooting off screen.
And that is surprisingly accurate to the physics of what they are doing. They half open their wings, flapping frantically to generate upward lift, but keeping their weight just heavy enough that their lobate feet can rapidly slap the surface tension of the water.
So they literally run on the water.
They literally run across the surface of the river, leaving a massive splashing wake, and dart directly into the thickest, most impenetrable tangle of roots they can find.
And apparently that scrambling speed translates perfectly to dry land, too. The sources mention that if you catch one out in the open on a river island, they don't awkwardly waddle back to the water. They run at this scurrying, Franklin-like pace.
Oh, they are sprinters when they need to be. Their center of gravity is low, their legs are incredibly powerful, and they just vanish into the brush.
But this explosive, splashing, running escape brings us to a massive, glaring paradox that the experts in our sources are actively debating.
Right, the flight paradox.
Yes, the paradox of flight. We have a bird that possesses a wing claw, specifically because it prefers to climb trees rather than fly up into them. A bird that runs across the water in a panic rather than taking flight. Field researchers explicitly state they have never seen a finfoot in full, sustained, high-altitude flight. Yet these birds exist across vast, completely isolated river catchments throughout Africa.
It is the ultimate biogeographical puzzle. If you look at a map of African river systems, you have these distinct watersheds separated by hundreds of miles of arid savanna, mountains, and dry scrubland.
Right, huge deserts, essentially.
If the finfoot truly cannot fly, or refuses to fly, How do you explain a genetic population existing in two completely disconnected river systems?
I mean, they can't just walk across a desert, so the logical deduction has to be that they can fly. And not just short hops, they must be incredibly strong endurance flyers.
Exactly. The sheer existence of their distribution map proves they are capable of massive dispersal events. The mystery isn't if they fly, but how and when, because no human is witnessing it.
Right. If they're flying hundreds of miles, how is nobody seeing it? I mean, birders are everywhere.
Well, the primary hypothesis fundamentally flips our understanding of their behavior. If a bird relies on absolute stealth and camouflage during the daylight hours, taking to the open sky at noon is suicidal.
The eagles would see them immediately.
The eagles would pick them off immediately. Therefore, experts theorize that when a finfoot needs to disperse to a new river system, it waits until the absolute dead of night.
Oh, wow.
Under the cover of total darkness, it abandons its heavy, stealthy persona, launches into the air, and flies high and fast to cross the perilous dry land.
That gives me chills. This shadow-dwelling, climbing anomaly secretly launching itself into the midnight sky to colonize a new world. It completely changes the narrative of the bird.
It really does.
And the sources point out a very similar debate regarding their ability to dive, right?
Yes, exactly. For an aquatic bird, diving is the most fundamental survival tool. Think of a cormorant or a loon. They vanish underwater for minutes at a time. But researchers observing the finfoot note they almost never perform deep, sustained dives.
Really?
Yeah, their foraging is restricted to the surface. They might dip their head in a beak's length, but they don't plunge.
But if a predator attacks from above, why wouldn't they just dive deep?
It essentially comes down to buoyancy and energy conservation. Their bodies are incredibly buoyant, designed to ride high on the surface among the floating debris. Forcing that buoyant body deep underwater requires massive energy.
Oh, like trying to hold a beach gull underwater.
Great analogy, yes. Experts assume they could submerge entirely if an African fish eagle was inches from their back and there was no root system to hide under. But submerging is a last resort. Their primary instinct is horizontal evasion, swimming low, keeping only the head above water and slipping into a crevice.
Okay, so we have this water trapper running on water, clambering through the reeds, constantly analyzing the risk in the shadows. All of this high-stakes evasion requires serious calories. What is it actually looking for? Let's talk about the finfoot's menu.
They are restless, obsessive hunters. Their diet is broad but heavily biased toward aquatic invertebrates. We were talking about water beetles, small freshwater crabs, prawns, shrimp, and an enormous number of adult and nymph dragonflies.
Dragonflies make sense, given that the finfoot is constantly scanning the water's surface with its polarized vision.
But the menu expands because of their unique habitat. Because they hug the banks and forage under the overhanging roots, they have access to a massive terrestrial buffet that other water birds miss.
So they eat land bugs, too.
Exactly. They pluck spiders, millipedes, termites, and grasshoppers straight off the muddy banks and low-hanging leaves.
It's a really opportunistic mix. But my absolute favorite detail about their foraging behavior is how they exploit other animals in their environment to save energy. They aren't just passively waiting for a beetle to drift downstream. They actively use megafauna as tools.
It is a stunning display of interspecies commensalism. Finfoots have been widely documented actively trailing large mammals that enter the water.
I love this part.
If a pod of hippos or a herd of forest buffalo wades into the shallows, the finfoot will immediately fall in line behind them.
And crocodiles.
Yes.
We cannot gloss over this. There's a verified, documented observation of a female finfoot intentionally swimming directly behind a massive crocodile as it moved through the shallows.
Which requires an enormous cognitive leap for a prey-sized bird. To look at a crocodile and see it not as a threat, but as a utility. As these massive, heavy animals drag their bodies through the mud and thick reeds, they physically churn up the sediment.
Like a tractor.
Exactly. They disturb the root systems, which flushes out hundreds of hidden insects, buried crabs, and resting frogs.
It's brilliant. The hippo, or the croc, is doing all the heavy lifting, acting like a giant biological plow, and the finfoot is just hovering in the wake, picking off the terrified bugs that get displaced. Why burn the calories digging through the mud when you can let a 2-ton animal do it for you?
Work smarter, not harder.
But wait, you mentioned frogs. That means they're eating vertebrates, too.
Oh, yes, they absolutely cross the line into active carnivory. Their diet includes frogs, small fish, and even snakes.
Snakes. Okay, if this bird is wrestling snakes and swallowing fish, what is the upper limit? Could they eat another bird?
The sources explicitly confirm this, actually. While it might not be their daily staple in the wild, there is a documented, peer-reviewed record of a captive finfoot snatching a bronze mannequin, a small, highly active finch, and eating it whole.
Oh, my goodness.
The researcher who documented it concluded very simply, anything goes, really.
That totally shatters the delicate image of a little bird bobbing along eating water bugs. If you are a small animal and you fit inside that bright orange beak, you are lunch. They are fierce, opportunistic predators.
It is a high-stakes, high-energy lifestyle. They are constantly moving, constantly assessing threats, hunting relentlessly.
But that solitary, hyper-vigilant existence has to completely change when it's time to pass on those genes. I mean, how does a bird that relies entirely on invisibility and solitary stealth manage the most vulnerable, chaotic process in nature, raising chicks? When does a finfoot even decide to breed?
Everything about their breeding cycle is dictated by the hydrology of the river systems. In southern Africa, their breeding season is incredibly narrow, generally running from September or October through to February.
Which perfectly coincides with the wet season.
And the timing is a matter of life and death. The female must time her egg laying so that her chicks can hatch and develop enough mobility to escape before the absolute peak of the late summer floods.
Oh, because the water rises.
If she calculates the rainfall wrong, the river rises, the current accelerates, and the nest is simply washed away into the ocean.
Wow, so nest placement is everything. Given that they clamber up trees and hide in shadows, I assume they aren't building a neat little cup nest on an exposed branch.
No, the nest architecture is purely functional and heavily hidden. They build bulky, messy platforms of dead leaves, twigs, and reeds, usually positioned on a horizontal fork of a fallen tree, or deep within a thick stand of reeds, suspended roughly 1 to 3 meters directly above the water.
The sources noted a really fascinating architectural quirk about the nests built in the reeds, specifically how the bird enters them.
Yes, observers noted that reed nests frequently feature a customized structural ramp.
A ramp.
Because the finfoot doesn't fly up to the nest, it climbs out of the water. Its constant heavy foot traffic up the same path physically bends and crushes the reeds over time, creating a dense interwoven gangplank leading straight from the water's surface to the rim of the nest.
A custom-built ramp for a clambering bird. Now we have to talk about the labor division here. Who is doing all this complex, heavy lifting?
The female shoulders almost the entire reproductive burden.
Almost the entire burden.
She gathers the materials, builds the nest, incubates the eggs, and physically rears the young. The males are essentially phantoms during this entire process.
Wow. She builds the ramp, lays the eggs, and the male is nowhere to be found.
She typically lays 2 to 3 eggs. They are beautifully adapted, glossy with brown and slate blotches. Observers often note they look exactly like miniaturized crane eggs, which makes perfect sense given their genetic lineage. They blend perfectly into the dead leaves of the nest.
But the complete absence of the male brings up a massive, juicy piece of behavioral speculation from the evolutionary biologists in our sources. The question of finfoot monogamy.
It's one of the most debated aspects of their ecology. Any field guide will tell you that encountering a female finfoot is significantly more common than encountering a male. Females appear bolder, they are seen foraging more openly, and they are the only ones seen at the nest.
Which immediately begs the question, is the population naturally skewed? Are more females born than males? Or is there a behavioral structure hiding the males?
Biologists suspect it's the latter, pointing toward a mating system called polygyny.
Meaning one male mating with multiple females.
Correct. The theory relies on the concept of resource defense. A prime stretch of river, one with perfect overhanging cover, slow-moving water, and abundant prey is incredibly rare. A dominant male might aggressively claim and fiercely defend this premium territory from all other males.
Like a landlord.
Exactly. Because this real estate offers the highest chance of survival for chicks, multiple females will choose to build their nests within his borders. The male provides the secure territory, but the evolutionary trade-off is that the females must do 100% of the rearing work.
That makes sense.
It perfectly explains why you see clusters of females and lone chicks without a single male participating in the domestic duties.
That is fascinating. Like, I will secure the fortress, but you are entirely on your own with the kids. And the sheer physical dedication required from the female to pull that off is staggering. Talk to me about her incubation stamina.
She embodies the absolute extreme of stealth-based incubation. When she sits on those eggs, her camouflage is her only weapon. She will not flush. Even if a human researcher wades into the water and gets within literal arm's reach of the nest, she will freeze and hold her ground.
Arm's reach. A duck would be halfway to the next county if you got within 30 yards.
She trusts her invisibility completely, and the endurance is phenomenal. Researchers tracking nesting behavior recorded a single unbroken incubation bout where the female did not shift, stand, or leave the nest for 3 hours and 41 minutes.
Nearly 4 straight hours, frozen like a statue, balancing her thermoregulation while hyper-vigilant for snakes or monitors.
And to achieve that perfect invisibility, she executes a brilliant, specialized behavioral quirk. We established earlier that her beak is a glaring neon reddish orange.
Yeah, bright beacon in the dark mud.
When she settled onto the egg, she physically contorts her neck, tucks her head down, and buries that bright orange bill deep into the plumage on her back.
No way.
She consciously hides her most visible feature, transforming her outline into nothing more than a mottled brown lump of dead foliage.
The physiological discipline is just incredible. But eventually, the math pays off and those eggs hatch. And this is where the finfoot differs wildly from a typical songbird. What emerges from the egg? Are we looking at blind, naked, helpless little aliens?
Not even close. Finfoot chicks are highly precocial.
Let's break down exactly what that means in terms of biological cost.
Precocial development is incredibly energy intensive for the mother before the egg is ever laid. Altricial birds like robins or eagles lay relatively cheap eggs, and the chicks hatch helpless, requiring weeks of feeding to develop.
Right.
A finfoot egg, however, is packed with a massive yolk, providing immense nutrients so the chick develops extensively inside the shell. When a finfoot chick hatches, it emerges fully covered in thick down, its eyes are wide open, and its neurological system is completely firing. It can sit upright the moment it leaves the shell.
So all the developmental heavy lifting was front-loaded into the egg.
Exactly. And the timeline for their mobility is shocking. Within 48 hours of hatching, if a predator approaches the nest, a 2-day-old chick can physically hurl itself out of the nest and swim proficiently away.
2 days old and already swimming for its life.
Yeah.
But out of all the adaptations, my absolute favorite detail about the chicks, and I think the detail that proves just how deeply this stealth programming is hardwired into their brains, is the bathroom protocol.
It is a breathtaking example of inherited survival instinct. You have to remember the olfactory environment of an African river.
Mm-hmm.
Snakes, monitor lizards, and genets possess incredibly acute senses of smell.
Right, they hunt by smell.
A nest filled with accumulating feces is a chemical beacon screaming vulnerable prey here.
So how does a chick that is literally hours old solve the smell problem?
Instinctively, without being taught. When a tiny finfoot chick feels the urge to defecate, it doesn't just go in the bowl of the nest, it physically waddles its way to the absolute outer rim of the nest structure, turns its body around, and defecates over the edge, dropping the waste directly into the river below to be washed away.
It is potty trained at birth. The neurological hardwiring to know I must keep the nest chemically neutral is just astounding.
It highlights the extreme evolutionary pressure they're under. Every single behavior from day one is optimized against predation. But despite the built-in camouflage, the mother's brutal 4-hour incubation bouts, and the chick's precocial instincts, the reality of the riverbank is unforgiving.
Yeah, the field data in the sources brings this all back to a sobering reality. What was the actual breeding success rate observed?
In the intensively monitored nests detailed in the sources, the attrition rate was brutal. Out of 6 eggs laid across 3 different nests, only 2 chicks managed to successfully fledge and survive. That gives a crude, real-world success rate of roughly 33%.
33%. Only 1 in 3 make it. It really grounds the conversation. We can marvel at the wing claws and the polarized eyes and the crocodile stalking, but at the end of the day, they're a deeply vulnerable animal fighting against massive odds.
They really are.
Which transitions perfectly into the macro view of their existence. Let's look at the biogeography and the conservation status of the finfoot. Where exactly does this biological marvel live?
They actually possess a surprisingly vast geographical footprint. They are resident across an enormous swath of the tropical and subtropical forest belts spanning West, Central, and Southern Africa.
So they require heat and heavy forestation.
Yes, But the macro map is deceiving because their microhabitat requirements are incredibly stringent. You can't just drop them in any river. They require unpolluted perennial streams, meaning the water must flow year-round, never fully drying up or stagnating into toxic pools.
Right, no stagnant puddles.
And crucially, the riverbanks must feature that dense, unbroken canopy of overhanging indigenous vegetation.
If the bank is cleared, the finfoot vanishes.
Precisely. And because of those hyper-specific requirements, the African finfoot is currently listed as vulnerable in South Africa.
What are the primary ecological threats driving that vulnerable status?
It is a textbook case of anthropogenic habitat degradation. The primary driver is the clearing of riparian zones, farmers and developers cutting away the overhanging trees and reeds, which instantly strips the bird of its only defense mechanism.
Taking away the shadows.
Exactly. Second is large-scale water extraction for agriculture, which reduces those perennial streams to muddy, impassable trickles. Finally, you have the devastating impact of alien invasive plants.
Like the water hyacinth mentioned in the reports.
Water hyacinth is an ecological nightmare for the finfoot. It forms a dense, impenetrable, floating mat across the entire surface of a river. A finfoot cannot swim through it, cannot forage beneath it, and cannot clamber over it effectively. It basically paves over their entire world.
So their historical rivers are being choked, drained, and cleared. But this is where the finfoot throws us perhaps its greatest curveball yet. We have a highly specialized, vulnerable species facing massive habitat loss. Yet, when researchers track their distribution in South Africa, the birds are doing something entirely unexpected. They're moving.
The historical distribution records reveal one of the most fascinating avian range expansions documented in the region. They are executing a slow, relentless march westward across the continent's southern edge.
Walk me through the timeline of this expansion, because the geography involved here is wild.
The data paints a very clear chronological picture. Let's start in the mid-20th century. In 1942, they established a recorded presence on the Kruger River.
Okay, the Kruger in 42.
Then there is a massive geographical leap. Decades later, in 1976, populations are suddenly documented much further west on the Groot Brak River. 10 years after that, in 1986, they've pushed even further, appearing on the Little Brak River.
They are continuously hopping westward.
And the momentum doesn't stop. In 2007, researchers were stunned to find them established on the Breed River within the Bontebok National Park. And by 2017, the frontier had expanded even further west along the Breed River near Robertson.
Okay, I have to stop you here because this goes right back to the flight paradox we debated earlier. You have a bird that is supposedly terrified of open spaces, a bird that uses a wing claw to climb rather than fly. How does a population of specialized shadow-dwelling skulkers cross hundreds of miles of arid mountainous terrain to colonize completely distinct, disconnected river catchments?
It forces a total paradigm shift in how we understand their biology. This westward march is empirical proof that our assumptions about their immobility are wrong. Dispersal theory tells us that when local pressures like drought or hyacinth invasions become too severe, an animal must migrate or die.
Right.
The finfoot chooses to migrate. And as we theorize, they must be executing these massive, high-altitude flights in the pitch black of night, navigating by instinct to find these new viable waterways.
It's an incredible testament to their resilience. When the river dies, they take to the stars. But it's not all natural expansion. The sources reveal a highly counterintuitive reality about their conservation in the modern human-altered landscape. Usually when humans build a massive concrete dam, it is a death knell for the local river ecology.
That is the standard ecological rule. Dams trap sediment, alter thermal profiles, block fish migrations, and completely disrupt the natural flooding cycles that shape riparian habitats.
But for the African finfoot, human engineering has accidentally created a sanctuary.
It's a fascinating twist. The sources specifically highlight the Zunning Dam in South Africa. While a dam destroys a flowing river, it creates an enormous, stable, permanent impoundment of water. As long as the margins of that dam, the quiet coves and inlets are allowed to grow thick, tangled indigenous vegetation, the finfoot will thrive there.
Why do they prefer the dam over a natural stream?
Because of climate volatility. During severe, multi-year droughts, natural streams evaporate into dry ravines. The finfoots living there perish, but a massive dam holds water through the deepest droughts.
Oh, it never dries up.
Right, it acts as an artificial climate refuge. Researchers conducting fish surveys on the Zunning Dam reported astonishing densities of finfoots. They were spotting 6 to 8 distinct individuals in a single morning boat patrol. For a bird that is usually solitary and elusive, that is a booming population.
It is the ultimate irony that a concrete monolith meant to tame the river is acting as an ark for the water trapper. Okay, so we know they're out there, we know they're moving west, and we know they're finding refuge in the shadows of the dams. Let's translate all this heavy biology into practical application. For the listener who's planning a trip to South Africa, who wants to lock eyes with this holy grail bird, let's give them the definitive playbook. If I am heading to the garden route, where exactly do I go?
The garden route is arguably the premier Finfoot destination. The sources cross-reference several highly reliable hotspots that you should pin on your map. You want to target the Gukama River, the Hujikral River, and specifically the Kerbooms River, which has documented breeding populations.
Are there specific vantage points I should look for?
Absolutely. If you are near Nature's Valley, the Devasalot Bridge is a legendary observation point. You should also prioritize the lower stretches of the Tsitsikamma National Park, specifically focusing around the storm's river mouth.
Okay, I have the locations. I'm standing at the Devasalot Bridge. How do I actually execute the search? Because based on everything we've discussed, I obviously cannot just hike loudly along the riverbank waiting to flush one out.
If you hike the bank, you will see absolutely nothing. First, you have to read the water. Do not waste your time staring at stagnant, algae-covered backwaters, and do not bother scanning fast-flowing whitewater rapids.
They need the Goldilocks zone.
Exactly. You are looking for clear, moderately deep, slow-moving water flanked by a heavy, overhanging forest canopy. Once you identify that perfect stretch, the strategy becomes entirely passive. You find a quiet, elevated spot on the bank that offers a wide field of view, you sit down, and you freeze.
You play by their rules. You become the unmoving rock. How long am I sitting there?
Well, one of the field experts in our sources documented staying perfectly motionless for over 2 hours in a single spot just to earn a 10-second glimpse. Patience is the only currency that Finfoot respects.
Okay, I'm frozen for 2 hours. What are my eyes actually scanning for?
Counterintuitively, do not look for a bird.
Don't look for a bird.
No! If you are looking for the shape of a bird, their camouflage will defeat you. You must look at the surface of the water. Scan the edges near the mud for a very specific, sharp, V-shaped wake cutting cleanly across the surface. That stiff, fanned tail leaves a hydrodynamic signature that gives them away long before you see the feathers.
Look to the ripple, not the bird. And what should I be listening for?
The auditory cues are subtle but distinct. Listen for a sudden, heavy plomp sound. That is the noise a finfoot makes when it slips off a roosting branch or a submerged log directly into the water. Additionally, keep an ear out for their territorial vocalization, which the sources describe as a loud, harsh, duck-like crack, crack, crack.
Crack, crack, crack. Okay, but what if I'm not on the bank? What if I decide to take one of those river excursions, like the canoe trips mentioned at Fairview Hotel's Finfoot Island?
Entering their environment on a boat changes the dynamic entirely, but the philosophy remains the same. If you are in a canoe or raft, abandon any aggressive paddling. You must let the boat drift silently on the natural current.
You essentially have to turn the canoe into a floating piece of driftwood.
Precisely. And you must retrain your focal point. Your instinct will be to scan the wide open water in the center of the river. Ignore it. You need to look deep into the shadows, into the tangled, chaotic matrix of exposed roots, undercut mud banks, and low-hanging branches.
Because that is where the camouflage is mathematically perfect.
Right, and because the camouflage is perfect, you aren't searching for a brown bird in a brown environment. You are searching for the biological anomaly. You are scanning exclusively for a flash of bright neon orange. Look for that reddish-orange beak or the sudden movement of a bright orange leg stepping against the dark, wet mud. That singular flash of color is often the only mistake the finfoot makes.
That is the ultimate piece of advice. Don't look for the bird, look for the orange in the dark. It's like hunting for a needle in a haystack, but occasionally the needle glows neon.
If you respect their habitat, if you put in the grueling hours, and if you truly commit to the discipline of stillness, they will eventually calculate that you are harmless, and they will oblige you.
The obliging skulker. We've covered an immense amount of ground today, unpacking the biology of a creature that almost defies belief. To try and synthesize the magic of the African Finfoot, well, it is an animal that exists as a living rebellion against our need to categorize nature.
It refuses to conform to the evolutionary expectations we place on aquatic birds.
It's a water bird that uses a built-in comb to groom its toes. It clambers up vertical tree trunks using a literal claw hidden on its wing. It bobs its head to stabilize its vision, relies on a woodpecker tail for balance, and will literally run across the surface of a river to escape danger, only to calmly swim behind a 2-ton crocodile to steal a dragonfly. It is an evolutionary oddball, perfectly engineered to rule the shadows.
And despite being so deeply tethered to those shadows, it possesses the secret capability to launch itself into the night sky, migrating across arid continents in ways we are entirely blind to.
Which leaves us with one final, haunting mystery pulled directly from the deepest footnotes of our sources. We talked about their harsh crack call, but there's another sound associated with the water trapper, isn't there?
Yes. For decades, isolated field researchers and locals living deep in the riverine forests have reported that the Finfoot possesses a second vocalization. It is described as a deep, resonant, booming song, but it is uttered exclusively in the absolute dead of night.
A sound that very few humans on Earth have ever documented or heard. So I want to leave you, our listener, with this challenge. If you ever find yourself traveling along the garden route, and you happen to be sitting by the dark, slow-moving waters of the Groot Brack or the Kerbooms River, long after the sun has gone down and the shadows have completely swallowed, the banks listen closely to the water.
If you have the patience to sit perfectly still in the dark.
If you are patient enough and still enough, you might just hear that deep, booming, secret song of a water trapper echoing through the reeds. The ultimate proof that out there, in the muddy, tangled waters of the natural world, there are still so many incredible mysteries we haven't quite figured out yet.